Good morning, everyone. I'm Robert Canfield, the Director of Marketing at Fresenius Kabi. I'm here to talk to you about the Ivenix Infusion System and give you a brief demo of the product. In 2019, the Ivenix Infusion System was cleared by the FDA. 10 years prior to that was when the roadmap for the product started. So this is the result of a decade of development, refinement, working with nurses and pharmacists to determine what was needed in the market. So they started with a clean sheet of paper and they said, what can we do to address literally all of the infusion issues that hospitals are dealing with today? What are the problems that nurses are facing with? Why are they burdened with setting up an infusion? Why are clinical engineers doing excessive maintenance on the devices? Why are they down in biomed for repair? What can we do to solve things and think differently? How can we solve the problems that were created in the beginning over 20 years ago when devices started in their design? So we started with breaking the mold, really. The same old thinking gives you the same old results is kind of our mantra. How are we addressing issues in the market and how can we solve those problems? So the Ivenix Infusion System is a large volume pump. There's a charging bracket that it connects to. There is software in the back end that supports clinical engineering, pharmacists, nurses. We have visibility to the status of the infusions. We have visibility to the devices down in biomed. The nurses can see what's going on with the infusions, the pharmacists can. Deployment of the drug library is very quick and wireless. And then we have a set of consumables, dedicated consumables that go with the device as well. So trying to reduce the infusion-related errors was the core mantra of dealing with what's wrong with the market today. What are the challenges with the existing infusion pumps on the market? So the product is well awarded. There are so many features that make the product differentiated for nurses and for biomeds as well. So the device detects the use of a duplicate medication across pumps. So if you have a pump that's infusing insulin on a patient that it's been assigned to, and the nurse attempts to program insulin on that different pump assigned to that same patient, the device will warn that nurse and alert them that that duplicate medication occurred. So if you think of modular technology in the market today, across a central monitoring system, for that infusion, that brain, if you will, can monitor across modules, but we found that it's more important to monitor for all of the infusions associated to that patient. Bags can be hung anywhere. So today's peristaltic technology, and I'll get into that a bit, really relies on gravity. So nurses are trained to raise and lower bags in order to administer a piggyback appropriately and on time, accurately, or as accurately as the device can deliver. We don't care about gravity. You can place the bags anywhere in relation to the pump. The pump can be anywhere in relation to the patient. So when you're doing your calibration checks in biomed and you're doing your preventative maintenance, one of your requirements is to take a tape measure and give the right amount of inches from the top of the water level down to the pump. We're immune to that. We don't care. That doesn't affect our calibration at all. The pump can actually pump laying on its back, on its side, upside down. If you think of what the devices go through when they're being transported, there's quite a bit that can happen, right? So we want to address real world scenarios on how accuracy is important for an infusion. There's a clear and simple touch screen. So the nurse unlocks the screen and can program very quickly. So if you know how to use a smartphone, you know how to use our devices, kind of our initial icebreaker for training the nurses. It's very daunting to take on a new ATM configuration or a flip phone configuration, remembering menus. We try to eliminate all of that for the nurses. And then I talked about the accuracy, and where the accuracy comes in is that the pump actually uses what we call pneumatic technology. So we have a pneumatic system inside the device. It's calibrated, so it calibrates every infusion as it's pumping. And there's two stages to it. So the pneumatic chamber here is kind of like, I say it and I kind of get in trouble with the marketing team, but it's kind of like the shape of a whoopee cushion. Think of that. So we apply pressure to that system and it will pump the fluid into the patient. what that buys us is we know consistently the pressure we're applying in that chamber, and we can measure against that. So if I'm measuring my flow here, I'm controlling the infusion very accurately. And then in order to level out those spikes and troughs that can occur with an infusion, I'm actually controlling the infusion with a dial here. So this little armature here will control the dial during the infusion and flatten out those spikes and troughs. And we've got a graph to show you that as well. Another advantage is we talked about the pneumatic technology. It's a dual inlet cassette. So we have our primary carrier fluid and then our secondary piggyback that we deliver. That whole, like, we don't care where the bag is located. What that also gives us is the ability to know that the bag is empty. And this is a bit unique in the market. We'll actually pump all the way down the tubing line and into the chamber. Once an air bubble hits that diaphragm that I talked about, the device senses that. It will kick the air bubble back up, and it will alert the nurse that the bag is empty, or it will kick over and push the primary fluid through for a flush. Okay, so a lot of technology, a lot of intelligence of design went into the product. When we remove the cassette, we actually have to have the device stopped. So the nurse will have to stop the device in order to remove the cassette. And that's so that this dial, this flow dial, can close, so that we're guaranteed a flow dial closure and no free flow. So there are a lot of issues in the market today with free flow with different devices. Plastic pieces are breaking and free flow can occur. This is intended to address that fully so that it's certain that it won't free flow. And then I think the most impactful for this group is no annual preventative maintenance is required. So I talked about the calibrated chamber inside the device and the pneumatic technology. Because the system is calibrated and calibrates itself during every infusion, there's no need for it to be calibrated annually or checked for a rate accuracy annually. And this was part of our 510(k) clearance with the FDA. Rather challenging to get through because it's a different way of thinking, right? We talked about new technologies and different ways of addressing issues in the market. Because of that calibration, there is no need to collect the devices annually and do preventative maintenance on them. If the team cleaning the devices inspects the devices for a hardware damage, you know, tough love, right? Nurses are kind of hard on devices. Should the device be damaged, it would be returned to Biomed, of course. But if that inspection occurs during cleaning, then there is no reason to collect the device throughout the life of the device for a scheduled reason. So I talked about peristaltic technology. So I always liken it to the idea of a child stepping on a garden hose and you get the squirt of fluid out. So peristaltic technology for infusion pumps works in a very similar manner, squeezing toothpaste through a tube, applying pressure to get fluid to move through a system. We took a completely different approach. So that diaphragm-shaped chamber you see there, the IV fluid comes in. There are valves controlling the flow of that fluid on the other side of that diaphragm. And then that pneumatic drive is driven by software that accurately controls and is calibrated throughout that chamber push to push the fluid into the patient. Air moves the diaphragm back and forth. It's measured. We know the calibration of the administration set. We're able to measure the air through that pneumatic system. Measuring air is equivalent to measuring the fluid because of Boyle's law, consistent pressure in a closed system. Software determines exactly what we should push for the rate and the pressure in the system. Because that diaphragm is actually monitored for pressure, we can know how much we're pushing and if we should push more for the condition. So what if the fluid is more viscous? What if the patient's blood pressure rises and you get more back pressure in the line? Various reasons can cause various levels of back pressure in the system. So we are the only device that actively controls and measures what we should deliver to the patient so that we get the most accurate infusion we possibly can. Some comparison studies were recently done and we were the most accurate pump in that study, and all of the major vendors were in that study. So we're very prideful of the accuracy of the device, and I'll explain to you why that really matters. Temperature, real world conditions, head height, anything that's affecting an infusion, we've compensated for with that technology. And then where it really matters is those high risk drugs, the half shelf life, things that, you know, we want to make sure we're delivering on time. If we were to forget a roller clamp, which can sometimes happen, the nurse starts the infusion, they go back and the roller clamp was closed and they didn't know it because the device they were using wasn't actively pumping that secondary infusion into the patient. If you've just got a Y site above and you're, you know, hanging and praying, we call it, right? You hope that you've opened your roller clamp, you hope that you've got your bags in the right place. Well, that Y site, we literally took all of the intelligence and in that kind of dumb piece of plastic and moved it into the cassette to make a very smart delivery and a very controlled delivery of that secondary infusion. So designed to be inherently safe, right? Unprecedented flow, unparalleled flow accuracy and continuity. So that continuity of flow is super important when we're dealing with high alert medications, medications that impact the patient directly. If we think of vasopressors controlling blood pressure, nurses need something that's very consistent so they can eliminate the device as the symptom or the problem in the system that's controlling the patient's blood pressure. And then this is my little garbage in, garbage out conversation. If we think about the roller clamp being missed and the pump thinking that the infusion started, but it didn't actually start, in this situation with control of that secondary infusion, we know that it started and we know that we're accurately delivering it. We're going to alert you that that roller clamp is closed. You'll come back and you'll open it and you'll start the infusion. So anything that's going to impact the accuracy of that infusion is going to alert the nurse or you know, be compensated for with the technology. What this buys us is the data generated by the infusion pump is going to be more accurate. If the machine delivering the infusion is accurate, the data generated by that machine is going to be accurate and going out to the EMR, going out to dashboards, reporting into biomed, reporting into pharmacy. We're getting more and more connected with our infusion devices and our medical devices, so having accurate data is critical for these systems. We have the ability to identify the patient at the device. So you can see Helen Edwards is my patient here, and I have a list of patients that are available to me as a nurse. This is a bit unique in the market as well. We connect to an admit discharge transfer system to populate those patients on the device and assign that patient to that pump. So that duplicate medication checking, the assignment of that patient to the data in the system without connecting to the EMR directly for the scan that you might be doing with your pumps today. Kind of a bridge solution so we can identify the patient and have a richer data experience with that data. I'm sorry, and one impact of that is billing and coding. So infusion services are charged based on accurate data, right? RAC auditor wants to make sure that the charges for an infusion services are accurate. So that accurate delivery is going to translate to that accurate data and give us a better billing experience. We're going to have to throw away fewer and fewer instances of an infusion delivery because we're not confident in that data. If we're confident in the accuracy of the data reported by a computer to a computer, we're going to have a better billing experience for our billing team as well. And we talk about the tough exterior a lot. So the device is made of a metal roll cage. So if you think of a four-wheel drive vehicle having a roll cage when it tumbles, if it were ever to turn over, if a nurse were to drop this, if it were thrown into a cart, what have you, the device is going to stand up to that tough love that we talk about nurses giving to the infusion pumps. So metal all the way around the device. You can see it at the bottom as well. And then the outside exterior is actually made of a polymer that will stand up to all of the harsh cleaners that that your facilities are using to clean the devices. Our research showed that devices, the plastics on the devices were failing because things like Cavicide were being used and they were tearing into the plastics, degrading the plastics and causing them to crack. So you can literally spray our device down directly all the way around. That's how you clean the device. You can scrub it with a brush, all of that good stuff. And you can use any of the normal cleaners that you might use today to fight those things like C. diff and COVID and everything else that's happening in the world. You can see that the edges are very smooth and rounded, and that's very intentional. Part of our clearance was subjecting the device to being swathed with bacteria and blood and materials that could contaminate a device, and then proving that we could actually clean that device really well. So that was our input to design and making things better and making things easier for everyone to clean and take care of. All those rounded edges and fewer crevices is intentional. And for HTM professionals, we realize that tracking down a pump is always something on the agenda. A nurse might report something, you've got to go investigate something about a device. You might have a device that's had some challenges getting an update of some kind. So it's usually top of mind in a conversation of, what are we going to do to track down these devices? So what we've done is given you the ability to track them down from anywhere. And you see the little fine pump icon. That fine pump acts as a locator, and that locator will actually pop up on the screen of the device itself. So you would send this message from your workstation down in Biomed, I'm looking for this device. It can display your phone number, your full name, and help you track down that device. So there are different levels of real-time location services, adding a puck to the device, all of that. RTLS systems can be very challenging, replacing batteries and all that good stuff. Our engineers said, well, what are the biomeds really trying to accomplish? They want to track down specifically a device or two or three, a straggler during an update, whatever that might be. And this is intended to address that, help you find those stragglers. I think I skipped over a little bit. Talked about no calibration needed, remote troubleshooting, and transparent software updates. So the drug library for our device is very different. If you're working on pumps today, very likely your drug library is sent out by your pharmacist. The pharmacist will send you an email or a phone call and say, we're doing a drug library update, I need your help. Please go track down devices that are not updated. Can you look on the screen for the version of the drug library, whatever that might be. Labor for your hospital, interruption for your nurses because you're tracking down work to maintain equipment. We've eliminated all of that effort. So pharmacy will deploy a drug library to our device. The device is updated in the background. So you have a base database of your drug library on the device, and then we'll send iterative changes to that drug library. So let's say you were going to change dopamine and you would send out a change to dopamine that day. Every device running would get the new setting for dopamine. If a device were running dopamine, it would wait until that case were over, and then it would update dopamine for that device. So very selective. And in that scenario, you can see there's no impact on the nurse. There's nothing for the nurse to do. They don't have to power down the device. They don't have to wait 3 minutes for something to update. It's just immediately there on the device. So that should eliminate your phone call from pharmacy saying, I need your help with updating the drug library. I'm seeing nods, so that's encouraging. All right. So in a nutshell, we're all tasked with doing more with less. And Ivenix and the Fresenius Kabi folks sat down and said, what can we do to help everyone in the market to have a greater reduced burden? Let's remove the burden from the nurses. Let's remove the burden from the clinical engineers. Anything and everything that you need to do to this device is wireless. So if you need to get logs from the device and pull them off, the system will allow you to do that over the wireless network. there is no scheduled reason to collect the pump for the life of the device. Now, if you have a hardware issue, of course, you're going to have to collect, that specific device and repair the device. Nothing is impenetrable. Things get squashed and run over, and bad things happen to devices. We all know that. But making something incredibly durable that's going to stand up to that tough love should make it so that you purchase the device and deploy them and have very few reasons to touch the device thereafter. Full calibration, it sounds a little bit scary, but we've been in the market since 2019. We're live in various hospitals throughout the nation. It is working, and the biomeds really do love it. So it is working really well. And then that kind of segues for a lot of HTM professionals of our right to repair. We want to still be trained on repairing the device. We want the ability to repair the device. So we do have a list of things that you're able to repair on the device. We're going to give you education and the right materials to support you in doing that. But as I said, the only intended reason for collecting the device would be to replace a battery. Of course, the battery has a life. The battery's life is approximately 2.5 years, but we're also going to report to you on the health, not just the charge level, but the actual health of that battery. And once the battery reaches a 70% and it can no longer deliver at the, the length of time of an infusion that we recommend as a manufacturer, then we're going to give you that report and tell you that battery's due to be replaced. We expect that to be at the 2.5-year mark. But anyone in technology knows the more you use a battery, the sooner it's going to need to be replaced. The less you use one, the less frequent it needs to be replaced. So batteries will be dynamic for you. You'll only need to replace devices that are going to be due for a battery replacement. And you can actually go in and check the status of the device and find the life of that battery.